A seismic rupture is tearing through the California desert right now, today, not slowly grinding over centuries, violently, a magnitude 7.3 earthquake that unzips the earth for over 50 miles. That is not a fictional story. That is not a worst-case scenario. That is the measured, documented reality of what happened on June 28, 1992, near Landers, California. The ground shook so hard it changed the map. But that is not the part that broke geology. This is, at the exact same time, 1,000 miles away, seismographs inside Yellowstone National Park began screaming. Hundreds of tiny earthquakes, a seismic swarm appearing out of nowhere. There is no fault line connecting Landers, California to Yellowstone, Wyoming. There is no physical crack in the North American plate that spans that distance. The two locations are separated by the entire Great Basin, by 1,000 miles of solid continental crust, and yet the data was undeniable. When California shook, Yellowstone shook with it. Not as an aftershock, not a coincidence, a direct response. So, what happens when a force you can't see connects the most famous fault zone in the world to its most famous supervolcano? Here is the number you need to hold in your head. 1,000 miles. That is the distance separating the San Andreas fault system from the Yellowstone caldera. To put that in terms you can picture, it is the distance from New York City to Omaha, Nebraska. It is the distance from Paris to Warsaw. And it is the distance that seismic energy has now repeatedly, definitively proven it can cross to trigger earthquakes in Yellowstone. That is not a theory. That is not a fringe hypothesis from a sensationalist website. That is the established, peer-reviewed science of dynamic triggering. A phenomenon that was barely understood before the morning of June 28, 1992. On that day, the Landers earthquake sent seismic waves radiating outwards, not just along the ground, but through the deep rock of the continent. These were not the jolting waves that knocked down buildings. These were long, slow, powerful surface waves, ringing the entire planet like a bell. When those waves rolled through the Yellowstone Teton region, they did something scientists had never witnessed before. The waves squeezed and stretched the rock, momentarily changing the pressure in the vast, superheated network of water and steam that sits beneath the park. Think of it like sloshing a bathtub. The water, already under immense pressure, was jostled. That jostling was enough to make tiny, pre-existing, critically stressed cracks in the earth finally slip. The result was a swarm of hundreds of micro-earthquakes, almost all of them too small for a human to feel, but perfectly clear to the instruments of the Yellowstone Volcano Observatory. Seismologist David P. Hill and his colleagues at the USGS were baffled. Then they were convinced. They published their findings in the journal Science in 1993, giving a name to a force that had been invisible until that moment. Dynamic triggering. An earthquake in one place causing an instant seismic response in another, far, far away. It was not a one-time event. On October 16, 1999, a magnitude 7.1 earthquake struck a remote part of the Mojave Desert at Hector Mine, California. Within minutes, the seismographs at Yellowstone lit up again. Then, on November 3, 2002, the real test came. A colossal magnitude 7.9 earthquake ripped along the Denali Fault in Alaska, more than 2,000 miles away, an impossible distance, and yet the now familiar signature appeared. Yellowstone's plumbing sloshed, the ground trembled. The connection was real, it was repeatable, and it worked over distances that defied all prior understanding. And here is the part that should stop you cold. The earthquakes in California are not stopping. And the tectonic system there is changing in ways that even scientists are still struggling to fully comprehend. The story we've been told about California's earthquake risk, the one that focuses on a single, infamous fault line, is dangerously incomplete. The San Andreas Fault gets all the attention. It has the name recognition, the Hollywood movies, the decades of built-in fear. It is a 750-mile-long scar that marks the primary boundary between the Pacific Plate and the North American Plate. For a century, geologists have seen it as the undisputed source of California's Big One. But what if it isn't the only story? What if the ground itself was shifting its allegiance to a new, more complicated, and more active system? 40 miles east of the San Andreas, a different kind of crisis is unfolding. It is a 500-mile-long zone of chaos that runs along the California-Nevada border. It is not a single clean line. It is a diffuse belt of hundreds of smaller, crisscrossing faults, a shattered landscape. They call it the Walker Lane Deformation Belt, and it is slowly tearing North America apart. This is not dramatic shorthand. This is a precise geological process. The Walker Lane currently absorbs between 15 and 25% of the total tectonic motion between the Pacific and North American plates. Think of it as a bypass lane on a freeway. For millions of years, almost all the traffic was on the San Andreas. Now, a significant and growing portion of that movement is diverting inland, taking a shortcut through Nevada. The rate of movement is measured, about 12 millimeters a year of right lateral shear. That doesn't sound like much, but it is happening every day, every year, relentlessly loading stress onto a network of faults that were once thought of as secondary. On April 13th, 2026, the quiet reality of the Walker Lane became headline news. At 6:29 in the evening, a sharp, jarring earthquake struck western Nevada. The USG's servers lit up. Magnitude 5.7. The epicenter was 12 miles southeast of a small town called Silver Springs. This was not a minor tremor. It was a significant regional earthquake, strong enough to shake buildings, rattle nerves, and remind everyone in Reno and Carson City of the forces moving beneath their feet. More importantly, it occurred directly within the Walker Lane structural zone. Geology professor Sean Wilsey, a prominent science communicator from the College of Southern Idaho, was among the first to publicly document and explain the event. He didn't talk about the San Andreas. He talked about Walker Lane. He explained how this was not a random event, but a symptom of this larger, ongoing tectonic shift. The quake was a data point, a violent confirmation of what the GPS sensors had been saying for years. This zone is active, it is accumulating strain, and it is capable of producing major earthquakes. The April 2026 quake was not the start. It was a continuation, a pattern. The 2019 Ridgecrest earthquakes in California, the ones that sparked massive online panic about Yellowstone, also occurred in a similar tectonic setting, on the eastern edge of the Sierra Nevada, where the Walker Lane system begins to feather out. A magnitude 6.4, followed by a magnitude 7.1, and just like in 1992, 1999, and 2002, the seismic waves from Ridgecrest traveled 1,000 miles and dynamically triggered a small earthquake swarm in Yellowstone. This brings us to the question that powers an entire subgenre of internet fear. If a magnitude 7.1 can make Yellowstone twitch from 1,000 miles away, what happens when the big one finally hits? What happens when a true magnitude 8+ rips down the San Andreas, or the Cascadia subduction zone off the coast of Oregon gives way? Will that final, catastrophic shake be enough to uncork the supervolcano? The answer, according to the scientists who monitor Yellowstone every single day, is no. Michael Poland is the scientist in charge of the Yellowstone Volcano Observatory. He is a geophysicist with the USGs. His job is to replace speculation with data. After the 2019 Ridgecrest quakes, he wrote a direct and unambiguous statement for the public. He asked the question himself, will these earthquakes trigger volcanic eruptions, including perhaps at Yellowstone? His answer was just as direct. Spoiler alert, no. The reason is simple, and it comes down to the fundamental physics of a volcano. An eruption isn't like popping a champagne cork. It's not a system just waiting for one final shake to blow. The magma chamber beneath Yellowstone is not a giant cavern of liquid-hot magma. That is a cartoon. The reality, confirmed by years of seismic imaging, is that the reservoir is a vast region of hot, but mostly solid, rock, acrystalline mush. The best estimates from the USGs place the amount of actual liquid rock, or melt, at just 5 to 15%. To trigger a super eruption, an earthquake would have to do more than just slosh some water around in the hydrothermal system. It would have to fundamentally change the pressure and chemistry of that deep magma reservoir. It would have to provide an enormous sustained injection of energy, far beyond what even the most powerful seismic waves from a distant earthquake can deliver. Michael Poland put it plainly, Earthquakes like those of the past week are unlikely to trigger volcanic eruptions, although they might trigger micro-earthquakes at some volcanoes. Read that again carefully. Triggering micro-earthquakes is a documented fact. Triggering an eruption is a geological impossibility. The energy is of a different kind and a different order of magnitude. The fear of a California earthquake causing a Yellowstone supereruption is based on a misunderstanding of both. It confuses the twitching of the park's skin with the stirring of its heart. And here's the part nobody is talking about. While the world focuses on the spectacular, imaginary threat of a volcano, the real, documented dangers of Yellowstone are getting worse. The threat isn't magma. It's boiling water. On June 13th, 2026, a hydrothermal explosion blew apart a section of Biscuit Basin in Yellowstone National Park. This was not a prediction. This was not a model. This was a documented event, confirmed in the July 1st, 2026 monthly update from the Yellowstone Volcano Observatory. Without any warning, a pocket of underground water, superheated by the magma deep below, flashed violently into steam. The force of that expansion blew a crater in the ground, hurling rocks and boiling water tens of feet into the air. The explosion was significant enough that it temporarily turned the nearby Firehole River muddy with ejected sediment and debris. This was not an isolated incident. It was smaller, the WIVO noted, than a previous, highly publicized explosion in the exact same area that had occurred in July 2024. That earlier event at Black Diamond Pool was powerful enough to completely destroy a park boardwalk. This is the real and present danger at Yellowstone. Not a volcano that may or may not erupt thousands of years from now. It's the ground itself, which can and does explode without warning. These hydrothermal events are happening now. They are part of the normal, violent life cycle of the caldera, and they are utterly unpredictable. Think about the contrast. The internet is consumed with a phantom chain reaction, a California quake triggering a Wyoming eruption, a cinematic, apocalyptic fantasy. Meanwhile, in the real world, the documented events are quieter, more localized, but no less threatening. A magnitude 5.7 quake in Nevada, confirming that a vast secondary fault system is becoming more active. And a fresh crater in the ground at Biscuit Basin, confirming that the most immediate threat in Yellowstone is the water, not the rock. The numbers for June 2026 at Yellowstone tell the entire story. In that month, the park recorded exactly 118 earthquakes. The largest was a trivial magnitude 2.4, completely unnoticeable to any visitor. The caldera itself showed no signs of significant uplift or subsidence. By every metric the IVO uses to measure volcanic unrest, the system was stable, normal background levels. Yet, in that same month, the ground exploded. That is the paradox of Yellowstone. The system is so vast, so powerful, that we focus on the hypothetical cataclysm, the super-eruption that would end civilization. We fixate on external triggers, like the San Andreas, because it provides a simple, linear narrative of cause and effect. But the caldera doesn't operate on our narrative timescale. Its most frequent and dangerous expressions are not the ones we write movie scripts about. The Walker Lane continues to move 12 millimeters a year. Some geologists have a theory for where this is going. Their models suggest that over the next several million years, the Walker Lane system could become the new primary plate boundary. The San Andreas would grind to a halt, its geological role complete. The entire tectonic system would have shifted east with a massive block of California, including the Sierra Nevada mountains, shearing off from the rest of the continent to become a long, thin island off the coast of Nevada. This is not a certainty. It is a projection, a geological forecast on a timescale that is difficult for a human mind to hold. But it is a future based on the real, measured movement that is happening today. But that future, however dramatic, does not point toward Wyoming. The northern end of the Walker Lane system terminates in northeastern California and northwestern Nevada, near the Modoc Plateau. It is extending northward, but not northeast. It is not building a bridge to Yellowstone. It is building a new coastline for a future Nevada. So, the fault crisis in California is not reaching Yellowstone in the way the headline implies. Not as a crack in the ground. not as a fuse leading to a bomb. The connection is both more subtle and more strange. The crisis is real, but it is a crisis of tectonics in the basin and range, a slow-motion breakup of the continent demonstrated by events like the Silver Springs earthquake. The events in Yellowstone are also real, but they are crises of hydrogeology, of superheated water and steam, demonstrated by the recurring explosions in Biscuit Basin. The two are connected only by the thinnest of threads, the invisible seismic waves that travel for 1,000 miles, a message sent from one zone of instability to another. The message doesn't say erupt, it just says, I am moving. And in the hypersensitive, waterlogged ground of Yellowstone, that whisper is enough to make the rocks tremble. We are left with a story about misdirection. We watch the San Andreas, the aging star, while a new protagonist, the Walker Lane, is taking over the scene. We watch the volcano for signs of the apocalypse, while the real danger is in the boiling mud pots and geyser basins we treat as tourist attractions. The earthquakes from California do not pose an existential threat to Yellowstone, but our misunderstanding of them poses a threat to our own sense of reality. Every time a California quake triggers a Yellowstone swarm, the cycle of panic begins again, fueled by the grain of truth that the connection, in some form, does exist. The dynamic triggering confirmed by David P. Hill in 1993 was a landmark discovery. It revealed a web of invisible influence, proving the Earth was more interconnected than we ever thought. Chris Ponkow, a seismologist at the University of Utah, later confirmed this, stating that dynamic triggering is a ubiquitous phenomenon, not just limited to geothermal areas. The entire planet is a resonating chamber. That is the scientific reality. The human reality is that we take that beautiful, complex science and flatten it into a disaster movie plot. The real story is harder. It requires holding multiple ideas at once. That the San Andreas is dangerous, but the Walker Lane is the future. That Yellowstone is a supervolcano, but it's not going to erupt tomorrow. And that the real danger is getting scalded to death. That California's quakes do affect Yellowstone, but not in the way you think. It is not a story of a single fault line reaching a single volcano. It is a story of a dangerously active planet doing thousands of complex things at once, and we are usually only paying attention to the wrong one. The ground beneath California is moving. The ground beneath Yellowstone is boiling. Both are true, right now. And the only thing connecting them is the